analyze, and we'll pick hash slot 7 to move as first hash slot. It will just connect to C and see, okay, C, please mark hash slot 7 as moving into D. What will happen is that every time C receives a request about hash slot 7, if the key exists in the dataset, it will just process the request. So all the old keys belonging to hash slot 7 will continue to live and be updated in C. If the key instead is not existing, it will reply ask D. What is the difference between ask and moved? Moved tells you please ask every kind of query for this hash slot in D. Ask instead tells you please ask just this request in the other node. Then the next request about hash slot 7 is again mine. Okay? So every new key will be created in D already. Okay? There is the problem that we need to move the keys belonging to hash slot 7 from C to D. This is done using the migrate command by Redis trib utility. So Redis trib will ask C, please give me a random key that you have in hash slot 7. If C will reply, I have no longer key belonging hash slot 7, the migration of hash slot is finished. Otherwise, C will reply with a key name, and Redis trib will see to C migrate foobar, let's say, into D. Migrate is an atomic command. It does a connection to D, C to D directly, transfer a compressed version of the whole value and the metadata as well, like if there is an expire set in the key. When the D node replies with, okay, I stored the key, C will remove from his copy. Okay? So migrate is completely atomic from outside. From the point of view of a client, a key can exist here or there. There are no race conditions. In the meantime, all the new keys will be created directly in D. So when all the keys will be migrated, we move at hash slot 7 without problems. What happens if D will go down while this process is in act, or C? There is always slave promotion, because Redis ether will mark the moving hash slot in D and all its slaves before to start with the process of migrating the keys. It's understandable what I'm saying. Please stop me every time you don't understand what I'm saying. Okay? So this is one of the problems we had to address with cluster. The other problem is, of course, that the cluster should stay up even if a few physical servers will crash, will get disconnected, and so forth. So this is how it works. There is this ping-pong exchange between nodes. When a node is idle, from the point of view of a given node, it starts to think, maybe this node is having issue, but will not do nothing without getting some acknowledge from another node. But maybe after I detect that a given node is down, I will get information via gossip about this node, and I'll figure out that this node is also down from the point of view of another node. Once I get an acknowledge, I mark the node as filing and will broadcast a message to all the other nodes, forcing all the other nodes to mark this node as failing. Okay? If the failing node is a slave node, it's not a big deal. We'll just will notify the system administrator that we'll add a new node, a spare one, that will be configured as slave and will resynchronize with the master. But if the node is a master, we need to perform slave master election. Okay, simply this work is up to the first slave. Slaves are ordered lexicographically in the string EP colon port. The first in the list of ordered hash-like is the one that should fix the condition. It will just elect, broadcast the message, and the cluster is up and running again. In 1-2 seconds should be everything okay again. Then okay, there is another interesting scenario. Sometimes nodes fail with strange patterns. The easy pattern is the IT guy will put the foot in the cable tongue and will disconnect. But when there is hardware failure, maybe it will be up, down, a few seconds up, a few down. This is a problem. But when the cluster will realize that there is to do promotion, this node is marked as failing, and when it will try to ping, or we will be able to ping him, we will send the message shut down now, and the node will shut down. If there is a huge split and the cluster understands every node refresh the configuration. If it starts thinking that the system is not consistent because, for instance, there are a few hash slots that are not served at all, it starts to reply to every query, even queries that it should be able to reply with errors. The cluster is down. Okay. And so we have to use Redis trib to restart the cluster from scratch. So what does this Redis trib do? Okay, it's used to set up a new cluster. You start a few blank nodes, then you say Redis trib, these are the IP addresses ports of my clusters. Please set up a new system, a new Redis cluster, and it will try to arrange the EP ports and slave masters so that the same so that if I have in a given physical box the A node, the slave of A is not in the same physical box. We will try to shuffle things for an optimal separation of slaves and masters. It's used to check the cluster for consistency. Think like FSGK, but not for file system, but for cluster. We'll analyze the cluster. We'll check if all the hash slots are in the right cluster, and we'll fix it if there are problems. And of course, it's needed to rebalance things. Maybe I have a working cluster, but I have a node that's getting too much queries because there is some key that is specially hit. It's important. So I can get basically Redis cluster. All the movements of key are decided by the user. Redis trib will have to get the work done. But it's up to you. Okay, it's more complex than this. There are a lot of details. Of course, every node will have an ID because it's not a good system to have configuration based on IP addresses. Maybe we can change an address and everything should continue to work well. So, in the configuration, in the memory of the clusters know each one using a SHA-1 signature, not the IP address. And well, the ping pong packet has a full configuration exchanged, so there is even the list of hash slots that a given node is handling, so the node can restart after a problem, even without using the cluster meet command that's used to rejoin the cluster. In a few seconds, all the nodes, thanks to gossip and the fact that there is full configuration exchange, will be able to start again. Okay, that's all.
Thank you.